Well, good morning. Okay, so I've had a couple of texts come in. I'm going to answer probably maybe 30 minutes would be my personal plan on Mod 6, and then I'd like to move on to Mod 7 since we spent both Tuesday and Thursday of last week doing Mod 6 homework problems. But again, it's your choice, so if you would like to spend more time on Mod 6 and the whole class is in agreement, that's fine. But I don't want to hold students up that are on Mod 7 and getting the help that they need to proceed. So also, today I know we're supposed to end the class at 10:45. However, I'm going to end it at 10:30 because my college algebra class takes their first online exam today, and it starts at 10:30. And I would like to be a little bit more accessible for that first 15 minutes in case a student is having challenges, so that I can assist them and help them get everything worked out so that they can successfully take the exam with minimal frustration on their part. And I'll do the same for you guys when you take your first online exam. So, alrighty. So the first problem that I have. That's hot. Thank you. Ouch. Okay, so the first problem I have, let me see here. If you sent me a text and I said I'm going to work on it today in WebEx, you might want to just send it to me again so that you're at the top of my texting. I had a student, let's see here, who is it? Kelsey Buck. Are you on WebEx today, Kelsey, right now? Let me see. I don't see Kelsey here, so we're not going to solve that problem then right now. And let me see here. If you're online right now, whoops. Feel free to send me a problem because I'm looking through my text. And I know Kelsey had one, and there was somebody else who had one, if I can find it, because I've been getting lots of texts from students. So, let's see here. Okay, I'm not seeing the other students. So please start posting questions on WebEx here. And if you need to be unmuted so you can talk, if you've got any questions, concepts that you need to not understand. And I'm learning how to unmute students one at a time. So, and if not, then we can just go on over to WebWork Homework and Mod 7 and start working it together. But how about some feedback, some input? Okay, let's see here. And I just realized I wasn't sharing my screen, so there you go. Now you can see my screen. So, good morning. I know some of you were there. Let's and I just heard something come in, so I'm going to go check that out. What do we have? Don't know about anyone else, but I would like to move on to Mod 7. Yes, Andrew, I agree. That's what I was saying. So I'm not getting any help on questions on Mod 6, so let's just go ahead on to Mod 7. So Andrew or Owen or Rowan, do you have any questions on Mod 7? Or do you want me just to start lecturing on new concepts? Or would you just like me to start working the WebWork homework? So Robin Lee, you have no questions on Mod 6, or you have no questions on Mod 7 that we've already covered? Working homework would be great. Andrew, do you have a particular problem you want to, thank you, Robin Lee. Do you have any questions on Mod 7 in particular, or you want me just to start with number 1, guys, and start working forward? Thank you. Okay. All right. Everybody's in agreement. Here we go. So we are on confidence intervals. And the one thing I want to say about confidence intervals, and I probably will just send out a PDF on this. I'm trying to be sensitive because I don't know who's personally been affected by the virus that's going around. So I don't want to bring up painful areas for anybody, okay? But one of the things that if you have been keeping an eye on the news and stuff, and I could easily show you on the CDC and stuff, if you go and you look, you're going to see 2 numbers often listed when they're looking at projections of what they're expecting to see, as in the number of cases that test positive in the United States, or maybe even per state. Those 2 numbers that you're seeing and you're looking at are actually confidence intervals, and that's what we're learning about right now. But right now, in real life application, anything with the CDC, there's lots of real life applications all the time with confidence intervals. But it would be easier for the students, for you guys to actually recognize, oh wow, that's what they're giving right now. And if you listen to like NPR, when they give those 2 numbers, they will often give you a little bit more information. They might give you a p-value, they might give you an alpha level, or they might say we're 99% confident or 95% confident. Those pieces of information are going to now give you more insight to actually what's being said and how to interpret their words that they're speaking and what the studies were done. So anyway, so there we have it. So we're going to start on problem 1. And I'm going to go ahead and just put it into my, let me look here first. It says a random sample of 17 size AA batteries for toys yields a mean of 2.99 hours with a standard deviation of 1.35 hours. Okay, there we go. Alrighty. So here's our first problem. If you look, it says right here a random sample of 17. Okay, so that's the first thing you need to write down is n equals 17. And then it says of triple or AA batteries for toys yields a mean of 2.99 hours with a standard deviation of 1.35. Okay, find the critical value T sub C for a 99% confidence interval, and then find the margin of error at a 99% confidence interval. That's the important information that I highlighted. Let me see why everybody's making comments. Did you lose me again? Rowan can see. It could be your personal internet connection. Let me make one adjustment on mine. And because I know I'm fine on mine, but let me put my hotspot somewhere else in the house that might be a stronger location. So hold on. Okay, is everybody good? Robin, are you good? I'm switching screens here. Can everybody see the screen with the problem on it with the notebook paper and my mouse moving around? Okay, good. Okay, great. Here we go. So here's what you need to recognize. The first thing for you guys, the easiest way to start off with this is the simple factor that right here we have this T sub C. That's the same thing. Well, no, it's not. It's your new distribution that we're going to be talking about, the T distribution. What we've been talking about up until this point is the Z distribution. The Z distribution is excellent when we know the population standard deviation. You will also hear If you go to UWF tutoring, possibly they're not supposed to be doing this, but sometimes it still happens. If you do online research, if you go to the internet to get your help and information, you will find that sometimes they will say, if you have a large sample size, N is 30 or more, then you use the Z. If N is less than 30, then you use the T, okay? That is a rule of thumb that a general guideline that a lot of people use. At UWF, this is not what we use, okay? And I would say then in real life application also, okay? If you know the population standard deviation, if we know sigma, you use Z. If you do not know sigma and what we have is the population sample standard deviation, you then use the T distribution. Remember, we're looking at confidence intervals, okay? And a confidence interval is a lower bound and an upper bound, okay? If we know the population standard deviation, that gives us a higher certainty of the results. And because of that, our confidence interval is going to be closer together. Our lower bound and our upper bound are going to be closer together because we're more confident of our results. If I do not know my population standard deviation and all I have is my sample standard deviation, now that's a standard deviation based on a sample, okay? Sometimes the sample size can be large, sometimes it can be small, okay? 17 it would be considered a small, okay? So if we're doing a confidence interval based on sample standard deviation to yield the same level of confidence, in this case here 99% confidence, our lower bound and our upper bound are going to be further apart, okay? We're going to have a wider interval to make sure that we're capturing the true population parameter mu, okay? So it's very important that you understand when to use the Z distribution and when to use the T distribution. Again, you will use the Z distribution when you know sigma. You will use the T distribution when you have a sample standard deviation denoted as S. One of the biggest challenges your guys are going to have is when you're reading the problems is determining what you're given. So pay attention to grammar, okay? I know that sounds silly, but pay attention to grammar. Notice it says a random sample of 17, okay, AA batteries for toys. The random sample for toys yields a mean of this with a standard deviation of this. So the random sample gave us the mean, the random sample gave us the standard deviation, okay? If the random sample gave us the standard deviation, that means we have S. If we have S, we are using T, okay? Everybody give me a thumbs up on here so I know that everybody is understanding what I'm saying. And Jordan, it looks like your mic is live, just to let you know that. Okay, excellent. So the next thing we have to do is we have to say, what in the heck is the T distribution, okay? The T distribution, I'm going to go over all that in our lecture today. So the T distribution is a distribution that was developed, I believe it was by a German, if I remember correctly, working for a beer company. Are we surprised? Where they needed to have confidence in the quality, I think it was the quality that they were producing, and they couldn't really do large samples. I don't know if it's because people got drunk or what, but they had to take and do small samples. And because the gentleman worked at a beer company, the company said he worked very hard and developed this distribution, which worked consistently well for small samples that come from normal populations. That's a caveat that you have to pay attention to. You can use the Z and the T when we come from normal distributions. You can use the Z also when you can invoke the central limit theorem, which says that if we have a large enough sample, then we know that the mean distribution takes on the normal distribution, okay? So the company that he worked for would not allow him to claim, we have Pythagorean theorem, we have all these different theorems and proofs and formulas that have special names that are named after the person who discovered them and put them together. The company he worked for would not allow him to do that. And so what he did is he called it the student t-distribution. He just said, I'm going to give students credit for it. So this is called the student t-distribution, or the student's standardized t-distribution. And this is how we're going to use it, okay? This distribution table, this actual one that you're going to be using for your classes, is different a little bit than what you might find in a textbook or online. And we've talked about that in the past, that the fact that in reference to the Z distribution, the one we use is a little bit different maybe than what you might find online or in other resources. But as long as you understand the concept, it doesn't matter, because they all have the same numbers. You just have to know how to use that table that you're looking at. So for this one here, this is the T, and we're going to have a couple of pieces of information that you need to understand. The first thing is right here, the 1-tel and 2-tel area. The top 2 rows here, you're going to ignore for right now. This all has to do with mod 8, okay? This all has to do with mod 8. For mod 7, you're going to be looking at this bottom row right here that I'm going across, okay? The one that says C right here, the very bottom row, that's what you're going to be using for mod 7. In fact, let me see about printing this out. Book over here. Oh, I forgot to add paper. Let me add paper real quick. And everybody help me keep an eye on my time, because I don't want to miss my 10:30 launch of college algebra. And as you all know, once I get teaching, I love to teach and I love my subject. I often forget to look at the time. So if you all could help me with that, I would appreciate that. Okay, that should be enough paper, at least to get us going for right now. Okay, here we go. So let me switch to this, to that, insert, file printout. There we go. And I heard somebody pop in here real quick, so I want to just look real quick just to see if I can. Yes. So Jessica, I am still working on this a little bit. In reference to printing it off to do your homework would be a good idea. My understanding right now is that the current testing environment will be such that online I will have to embed these options into your online test, which is fine. That's fine. I would prefer that you guys have the permission from the university to have your resources printed out, your formula sheet and your tables, for easier access during the exam. I don't know that I'm going to have the support to do that. So as it is right now, the current standing is all of these will be embedded into your exam as reference materials that you would look at on your digital device that you're taking your exam on. So that's the current situation. But for homework, definitely have it printed out. And I am trying to work it so where hopefully you will have the permission from the university to have your formula sheet and your tables accessible during your exam. So, okay. So here we go. All right, back over here to our tables. And now that I've got it in here, I can highlight. So again, let me just say right here, in case there was any confusion, this one here and this one here, you guys are not going to use for mod 7, okay? These are right here, mod 8. Now, this one right here is mod 7. Okay, so this is the row that you're going to be using for mod 7. That's what you use for confidence intervals. And the C right here, this tells you our confidence level that we're going to be looking at. And so let's just look at our first homework problem. It says right here, it says find the critical value T sub C for a 99% confidence. So they're saying, I want you to come in and I want you to find T of 0.99, okay? And then we're going to put a comma, and then we're going to put what's called degrees of freedom. So we put T sub C, comma, and then DF, where DF is your degrees of freedom. Okay, and your DF is equal to N minus 1. Okay, so your degrees of freedom is N minus 1. So in order to look up any critical values for T, you need the confidence level, which is 99%. So your confidence coefficient is going to be 0.99. And then you need your degrees of freedom. So for this one here, your N is equal to 17. Your degrees of freedom then is equal to 17 minus 1, which equals 16. So we're going to say that T 0.99, because we're looking for 99% confidence, comma, 16, because that's our degrees of freedom, is equal to, now we're going to come down and look at our table, and we're going to say, okay, let me switch my highlighter to red. There we go. Alrighty, so we're looking for 99. We're not looking for 0.999. The confidence level we're looking for is just 0.99. And here's our degrees of freedom. So the degrees of freedom, and then you have that bar. So it says this right here is our degrees of freedom. This right here is your C. Okay, so again, here's your degrees of freedom. Here's your C. So our degrees of freedom for 16 is right here. And then we're going to come all the way over to right here for 99% confident. And I don't think I'm in highlighting mode. So let me switch to highlighter mode real quick to make sure I've got that. So 16 and right there. So does everybody see that our T value is going to be 2.921? 2.921. 921. 921. Alrighty, so we're just going to go ahead and put that in web work for a minute. And so that was, yep, 2.291. 2.921, and we're going to hit submit answer. And there we have it correct. Alrighty. Again, everybody good. Thumbs up, folks. Thank you for Sadu and then Jessica. Okay, good. Thank you. Now, so we come, whoops, let me switch over here. So to solve part 2, it says find the margin of error. So for this right here, this is the 2.921. Now to find the margin of error. Are you surprised that our margin of error, okay, so we're going to be, instead of finding a Z score, we're going to be looking for a T score. Guys, watch your mic. Let's see here. Let's see who's here, who's live. Emily, it looked like, all right, here we go. So we can calculate a T value. It's going to be X bar minus mu divided by S divided by the square root of N. You're going to notice the only change in the formula is we don't have a sigma, we have an S. So it's the exact same thing that we've been doing. So we're going to come in and it says, Find the margin of error. So the margin of error, E. Oh, that was for the standardizing it. Sorry. For the margin of error. Sorry, confidence interval, folks, not just looking up the other. So it's going to be, let's see here. Our confidence level is going to be equal to x bar plus or minus t sub c comma df times s divided by n. So our margin of error is this part right in here. So our margin of error, E, is going to be our critical value, which is 2.921 times our standard deviation, which was 1.35 hours. 1.35 hours divided by the square root of n, which was 17. Grab your calculators, and I'll just go ahead and grab the one online here so everybody can watch. We'll clear it out, and so we have 2.921 times 1.35 divided by the square root of 17, and we get 0.9564. So 0.9564. So 0.9564, and let's go back to WebEx and see how many decimal places WebEx wants. It doesn't say, so 0.9564, and let's hold our breath and hope we get it right. Wahoo! High five, everybody. Okay, give me some feedback. How'd y'all do? Yes, this table is in Canvas. This table is located over here in Canvas. Before the semester started, when I set up Canvas, in here I have resources, which is tables and formulas, and there's the T-table right there. So you can go and get it off of the Canvas from tables and formula sheet. Okay, so did you step away for a second, Sadhu, or did you just miss it? Because I went over all of that. Okay, all right, got it. Okay, here we go. So, okay, so from the problem itself, it says that our sample size is 17. Well, sample size is what n is, right? So n denotes our sample size. So that's how I knew that right here needed to be a 17, because here's my formula, okay? And then S, our standard deviation, was also provided in the problem. It says standard deviation is 1.35 hours. So that's how I got the 1.35. And then this right here is our T sub CD, degrees of freedom rather, which is what we looked up right here. So this number right here went right here. My N went right down here. And then my standard deviation was also given in the problem. So does that answer your questions? And then let me go ahead, everybody, and pull up. We are, let's see here, on page 3. Okay, so we're switching to page 3 of our formula sheet. We've already talked about confidence intervals for mu when sigma is known. Okay, remember I talked to you at the very beginning of today saying when sigma is known, we're on the z distribution. Okay, when sigma is unknown, in other words, what we have is our sample standard deviation, we're on the t distribution. Both of these right here and right here are the margin of errors. So to calculate a confidence interval about mu for one sample, if your lower limit is going to be your point estimate, what's your point estimate? X bar minus your error. How did we calculate our error for this current one? It's right here. Okay, E is looking right there. And then how do we calculate our upper bound? It's our point estimate, which is X bar again, plus the error. Okay, so that's how you're going to be using your formula sheets. Okay, so now that we've done problem 1, let's move on to problem 2. Next problem. Okay, so here we go again with another T. I'm so glad you guys asked, as I did not realize that they start you off on T, and I apologize for that. So, okay, here we go. There we go. Alrighty. So it says, Justin is interested in buying a digital phone. That's nice information. It has no bearing really on what we're doing. It's fluff. So he visited 16 stores. That's important. Let me switch to something a little bit bolder. He visited 16 stores at random and recorded the price of a particular phone that he wants. Okay. So what did we learn? We learned our sample size is 16. Okay. So we know then that N is equal to 16. The sample of prices had a mean of $399.33. That is our sample mean. X bar is equal to 399.33. A standard deviation of 28.7. Again, it says the sample of prices had a mean of this. The sample of prices had a standard deviation of this. So, following our grammar, we know that this is S is equal to 28.7. So we do not have sigma, we have S. We have a sample standard deviation. In your exam, I'm not going to say what t-score should be used. I'm going to say, what is your critical value? Okay? Or what is your error? I'm not going to clue you in on whether you should look for a Z or a T table. Okay? That's part of the test, is you have to know which one to use. So you have to make sure that you're understanding and reading through the problems so that you understand. So it says, what t-score should be used for a 95% confidence interval about mu? So we're looking for our t-score. So if everybody wants to try it on their own, or, I'm going to walk through it, but if you want to just go ahead and tune me out for a minute and work on this on your own, remember it's T sub C, comma, DF. In this case, this is going to be, we're doing 95%, so it's going to be 0.95, comma, our degrees of freedom. N is equal to 16, therefore our degrees of freedom is equal to N minus 1, which is 15. So we're going to come over here to 15. So we're going to look up T, 0.95 and 15. Coming back over to our tables. Actually, I guess I can go back up right here. So we're at 0.95 confidence and our degrees of freedom is 15. So 15, 95 is right there. It's 2.131. 2.131. So right here, 2.131. And just to make sure we're not making any mistakes, we'll pop on over to WebWork and put that in. 2.321, is that right? 131. Okay, good thing I double checked. 131. There we go. All right. Now we're moving on to the next part of the problem. And it says, calculate a 95% interval for the mean price of this model of digital phones to 4 decimal places. Always pay attention to that right there. Okay? So we're just asking for the upper bound and lower bound. So our formula is going to look like this. Our confidence interval is going to be x bar plus or minus t sub c comma df times s divided by the square root of n. That's our formula. So to find our lower bound and our upper bound, it's going to be x bar, which is 399.33. So 399.33 plus and minus t, which is 2.131, 2.131 times standard deviation. Standard deviation is 28.7. So 28.7 divided by the square root of our sample size, which was 16 stores. Okay, so first we're going to calculate the lower bound. Always calculate the lower bound first. Okay, and then on the right hand side is upper bound. Because when it comes to numbers, we always go in numerical order of a number line. Okay, so we're going to grab our calculator out. And I'll bring that over here, turn it on, and I'm going to go 2.1, oh, no. Sorry, my eyes got the wrong spot. 399.33 minus 2.131 times 28.7 divided by square root 16. Enter. So we get our lower bound. It's set to 4 decimal places, so it's going to be 384 and then 0.0401. Notice that the 7 right here is going to round that up to a 1. Okay, so it's 384.0401. So 384.0401. So 384.0401, comma. That's our lower bound. Now we're going to go calculate our upper bound. Let me see if I can remember the trick here. If we go up 2 times and hit enter, it recalls the formula that we just put in. And the only thing we need to change on this is we need to change this negative right here, the subtraction, to a plus. So I can recall the whole thing instead of putting everything in a second time and put that as a plus and then hit enter. And that gives me my upper bound of 414 and then 0.6199. The 2 does not round the 9, so it's going to be 6199. So it's 414.6199. So 414.6199. I'm going to double check my memory on that one. Yes, the only problem with doing what I just did by bringing up the prior one so I don't have to type everything in again, if you made an error on typing in the first one, obviously you're going to duplicate that error on the second one. However, with that said, if you have all of this written down when you turn in your paper, because the way I'm going to have you guys do this on your exams, yes, your answers are going to be turned in on the computer. That's true. What I'm asking my students for algebra to do, and I'm going to ask you guys to do also, is you have 15 minutes from the time your exam ends, not from the time your exam ends, from the time you submit your exam. Okay, you hit submit on your exam. The next 15 minutes, you have 15 minutes to email me pictures of all of your work. So I'm asking everybody to take pictures, so when you take your exam on your plain sheet of notebook paper, problem 1, write down the problem, solve it. Then look at your solution that you wrote down on the paper, put it into the computer, okay? Go to the next problem, problem 2, copy the problem down. You don't have to copy the words down, okay? You don't have to copy all of the words that we have right here down. What you need to write down is the fact that it is problem 2, and then write down all of this information, okay? So if you had an error, maybe when you wrote down X bar, instead of writing down 399.33, you wrote 333.99 because you transposed your numbers, okay? When I get your copy of your work in, that you take a picture of and send it to me within 15 minutes of the exam, I'll see that you wrote that down wrong. And I'll double check your calculations. And if you have the concept right, I'm moving forward knowing that you understand the concept, and I'm not going to nail you, okay? I just have to figure out if I can find your error and if it's a simple mistake such as a transposition or whether it's an understanding mistake, okay? So hopefully that information will be beneficial to you. So our lower bound here, let's go ahead and put this in. So this is going to be 384.0401, and then this one here is 414.6199. So let's go ahead and put this into WebEx, or WebWork, sorry. So this was, what was it? 384.0104, so 384. So 384.0401, and then this one over here is 414 6199. 414 6199. So let's hold our breath and hope WebWork likes my answer. There we go. Okay. So I heard somebody pop in over here. Okay, so we did that. We got that. Good job that you got that. Okay, I'm a little mixed up on how you know if sigma is known or unknown. It's because you said sample size, so it's unknown, and if it's just a standard deviation, it's known. Okay, so Jessica, here you go. This is what you're asking is probably the hardest part of this whole section. Okay, once you get what you just asked figured out, the rest of Mod 7 is a snap. Okay, so that's the good news. Again, how do you know whether it's a population or a sample standard deviation? First off, if the problem says uses the word population or it is known. So sometimes you'll be reading the word problem and it'll say it is known from past history, or it is known that the standard deviation is whatever. Okay, that's telling you we know what the standard deviation is, and if we know what the standard deviation is, it is sigma. Okay, let me switch over here real quick. So if you're reading and you see the word population, whoops. Then sigma. If you see a phrase like, it is known that the standard deviation is a certain value, that's sigma, okay? It is known, okay? So it's telling you that from past history, okay? There's different key phrases that are going to say, but it is known is the big one. Now the other, what you need to look for is if it says we took a sample, so we took a random sample and found that the mean is whatever. And the standard deviation is whatever. This is S, okay? So we took a random sample, and from that random sample, so we took a random sample and found that the mean is blah, the mean of the random sample, and the standard deviation is, the standard deviation of the sample is, that's S, okay? So you have to read and pay attention to grammar. Grammar is so important on these problems. So let's just look, let's see if they have any on here that tests your knowledge on this. If not, I'll put something together for Thursday session to give you guys an opportunity to test your knowledge. But let's just look at these real quick. Already submitted, so next problem. Okay, let's look at this one. It says a random sample of n measurements was selected from a population with a standard deviation of this and unknown mean. Calculate a 90% confidence interval for mu for each of the following. In general, we can say that the confidence interval is increasing as the sample size, marge width decreases. Okay. An unknown mean. Okay, so a random sample of n measurements was selected from a population with standard deviation 11.1. Okay, right here, reading our grammar. Oh shoot, I'm not in highlight mode. Let me insert this into here. Okay, so coming in here, it says, so a random sample of n measurements was selected from a population with standard deviation 11.1. And it says an unknown mu. Calculate a 90% confidence interval for mu for each of the following. I'm going to hold my breath on this one. I'm just going to get honest with you guys. I'm going to say this is a Z, but because the fact that we've been doing T, I'm wondering if they're not saying that a random sample of n measurements was selected from a population, and then the sample had a standard deviation. I'm taking this as population, standard deviation, so this is a Z. That's how I'm going to work this, and I'm just going to hope that... yeah, okay, here we go. So in this case, it wants to know the lower bound and the upper bound. So we'll just grab our calculator real quick up here and bring this on over. And we're going to assume that we have to have the same, let's see here, does it give us a confidence on here? Random sample, calculate 90%, yeah, 90%, here we go, whoops, 90% confidence. So 90% confidence, if we come in here to... on also right here, okay, because they redid the tables to, instead of doing 1.645 and 2.575, they've got 1.65 and 2.58 seems to be the numbers that you have to use in order to get them right on WebEx. So I'm sorry, WebWork. So that's what we're going to look for. So 90% is going to be 1.645, but we're going to use 1.65 since we're planning on entering it into the computer. So 1.65 is what we're going to have to use. And so for this one right here, I just want to test one real quick. So it's going to be, mu is 7.9, 70.9 minus 1.65 times standard deviation of 11, yeah, this is population, 11.1 divided by the square root of 60. And so it's going to give us a lower bound of 68. How many decimal places does it say? I don't see. So 68.5355. So 68.5355. Let's just see if it'll let me put in that part or not. 68.5355. 5355. Let's just see if it lets us check that. Do you all see a number of decimal places? I don't see anything on that. So let's just see if that one. Yep. Okay. So Jessica, what clued me in, I just felt uncomfortable because UWF is typically really good about doing all T and then all Z and not necessarily mixing things up, not early on in the problems. In this case, they did, and that's fine with me. I just wanted to make sure that somebody didn't throw a monkey wrench in. So because it says population with standard deviation, it's this phrase right here, Jessica. I looked at the fact that it said population with a standard deviation of this. That told me that that is sigma, okay? And because it's sigma, I went to the Z distribution. Okay. Oops, over here. Okay, good. Would you all like to just, if I don't mind, guys, going ahead on this one right here, and we can just look at the next one and identify. So let's look at the next one here. It says plasma volume is an indicator of overall health for a person. Well, thank you for telling me that. I hate ads like that. If somebody knows how to keep things like that from popping up, please feel free to text me or email me that information. So, okay. So plasma volume is an indicator of overall health of a person. A random sample of 50 firefighters are tested and have an average plasma volume of 37. It is known that the population standard deviation is 8. It is known that the population standard deviation is 8. Everybody pop in here and put your answer. Is this Z or is this a T distribution? I'm not going to go look until I start hearing a whole bunch of clicks. Everybody make up your own mind. Is this problem here a Z or a T distribution? And anybody else? Excellent. It is a Z. So why isn't it T? The reason it's not a T is because it said right here, it says it is known that a population standard deviation is 8. So we have sigma. When we have sigma, we have a Z. So Alex, does that make sense? On this over here on the notebook paper, I put that right here. And one of the key phrases I said is if you see that it is known that the standard deviation or it is known that the population standard deviation is something, that's sigma. Oh, okay, yeah. You have to keep reading to see what it says specifically about the standard deviation. That's okay, no problem. Okay, let's look at the next one. Because that, honestly, guys, that's the hardest part. Once you get this part down, it's a piece of cake from here. Okay, the next one says, given data on the amount of quartz in a thin section from a ingenious rock, construct a 95% confidence interval with the mean amount of quartz in the rock. It says, so we're given raw data. Okay, and it says note that the sample mean is this. Okay, so they've calculated X bar for this data, and it says and S is equal to this. Well, it's S. So am I a Z or am I a T, guys? Everybody put in your response. Okay, excellent. Everybody, it is a T. Excellent. Let's do one more fun thing here. I'm not going to give you any hints. I just want to see who can get this, okay? I would like everybody to put in the T value, the T value with the appropriate degrees of freedom and the appropriate degree of confidence. So we are asked to find a 95% confidence interval, and I want you to give me the critical T value. Oop, that's wrong one. Let me open up, in case anybody doesn't have the t-tables with them. I'll open them up for you guys. There is enough information on the screen right now for you to solve the appropriate value. Anybody else want to try? Okay, so we had n, should have been 8 if I remember correctly off the top of my head. Let me double check that. So we have our sample size is 1, 2, 3, 4, 5, 6, 7, 8. So we had 8 in our sample. So n minus 1 gives us our degrees of freedom. So our degrees of freedom would be 7. So that's 7 right here. We need it to be 95% confident, which is right here. So we look at the intersection of 7 and 95, and so your critical value should be 2.365. 2.365. So let's bebop on over here and see who all got that right. 2.36. High five. Excellent, guys. Man, that is very, very good. Okay, so everybody else who may not have been brave enough to put your answer in, we're going to do this again, but let me ask you before we move on, do you now see how you would have gotten that critical value? For everybody who didn't feel like they, didn't have, want to take a stab at it, do you know how to do that now, or do you have questions? Thank you, Jessica. Anybody else? Good. Okay, let's look at another problem on WebEx, or WebWork rather. Next problem. Okay, Victoria is interested in opening her own candy store. She has researched and found that there are 12 stores that she investigated. The average startup cost was $101.7 thousand with a standard deviation of 29,000. Construct a 99% confidence interval for the average startup cost for the candy. So I'm going to ask first, is this T or Z? I don't want you to put the value in. Just tell me if this is a T or a Z distribution. Anybody else other than one person want to pop in? There we go. Good job, man. I like all those bleeps. Excellent. Everybody got it right too. I'm so proud of everybody. Now I'm going to pull up so let's look at the problem again. The problem has a sample size of 12 and we're looking for 99% confidence. Sample size of 12, 99 confidence. So now I'm going to pull up the t-tables and find your critical value. And put that in your answer then on WebEx. I have one brave person. Anybody else? We were at in case you needed to see the problem again, we are looking for a 99% confidence interval. We're on the T distribution, and our sample size is 12. So if our sample size is 12, your degrees of freedom is 11. Our confidence level was 0.99. So we're going to come over here to 11 and we're going to scroll right until we're underneath the 0.99. So it's 3.106. Excellent. Well, yes, Rowan, I'm not having you do so much your work. I'm looking at what's on the screen. Jessica, you got one off. Let's see here. Where's 3.05? 055. 3.055. Okay, so Jessica, you either accidentally went down a row. You may have been looking at 11, but by the time you got across, you dropped a row, or you misunderstood that you need to do n minus 1. So n minus 1 is the degrees of freedom. So it's 11, not 12. So if you had been writing everything on your paper and you had written degrees of freedom equals n minus 1, which equals 11, and then on the exam you had used the value 3.055, for the most part, I may have taken off a half a point, but that's about it, because that tells me that, and honestly, I probably wouldn't take off any, but I'll give myself on recording a 0.5 error possible. So because I know that you understood the concept and that you'd probably just grab the wrong value on the off the table. So let's see here. Whoops. Okay. It was one under. I need to print it out. It's hard to see on the screen. Yep, you're right, Jessica. Which is one of the reasons. Oh, thank you. I had no idea what time's been flying by. That's one of the reasons why I would really like it if you guys can print out your work for the exam. So just know I'm trying. Okay, just know I'm trying. Do y'all want to keep doing this? Is this helpful on working this? So let's see here. A survey of 1,000 large corporations, 250 said, given a choice between a job candidate who smokes and an equally qualified non-smoker, the non-smoker would be preferred. Construct a 95% confidence interval for the portion of corporations preferred for non-smoking candidate. Now, number 7, we're today's lecture we'll get into this also. Okay, so you're going to see on this one here. Let me insert this into our sheet real quick. Let me see. Thank you. Let me put this in our notebook so that I can write and add. Uh-oh. Come on. Let me close this out. Sometimes my OneNote freezes up, and when it does that, all I have to do is just restart it, because otherwise it just doesn't do anything else. So here we go. Okay. Insert. Screen clipping. And guys, if you're finding that this is beneficial and helpful, please reach out to your classmates and encourage them to come and participate. I think we're averaging, less than 10% of you guys coming and participating, which has me a little bit concerned. Not for you guys, just for them. So please encourage your classmates to either come and participate or at least watch the videos. Today, actually, I am recording us live, and if everything goes well, I will post not only the PDFs that we do from these, but I will also post a video, so anybody who didn't come today could watch this also. Alrighty, so as you're reading this right here, it says, this is our keyword right here. Our keyword is proportion. Okay, so we're now not looking at doing a confidence interval about mean, which is mu. Okay, so mean is mu. This one here is proportion. Whoops, that would be PR, not PO. PRO, PORTIN, and that is denoted as P. Sometimes you might see it a little bit of a fancier P written. It's a Greek P, and I'm not really good at writing Greek P's. Okay, let me just tell you that. So we have proportion. So just like the mean is mu for the population, proportion and population mean. Okay, we have, pretend that's Greek. Okay, just go with me here. A Greek P. If we have a sample proportion, and you'll notice in my notes for Mod 6, I had wanted to introduce this concept, even though you don't have homework on it, but I just ran out of time and couldn't get it in. I've redone my notes again for next semester, removing some of the lead-in slides that you all saw in hopes of trying to get to that information for next semester. But UWF doesn't typically present this information in Mod 6, but if we could, I think it would be better. So I keep attempting to try to get there. I just don't always get there. So sample proportion is denoted as P hat, where our sample mean is X bar. Okay, so we have population proportion and then our sample proportion. Again, going back to real life scenarios. I I've heard some arguments, and I'm going to tell you the numbers that I'm telling you are factual. Okay, I got them off the CDC. Some people are saying, well, I don't know what the big deal is about the coronavirus, because more people have died this year from the flu than the coronavirus. Okay, that is a true statement. More people have died this year from the flu than the coronavirus. And if you go to the CDC website since January, it will say something, unless the numbers have changed. This was last week that I looked, that the number of people who have had the flu, they gave a confidence interval, was between 31 million and 51 million people. Okay? And we've had between 20,000 to 40,000 people died from the flu this year. That's a lot of people. Yes, numerical wise, that is a lot more people than the coronavirus. However, what you need to look at is the proportion. That's what you need to look at. When you look at not the numbers of people that have died, but the proportion. When you run your numbers for the flu, you will find that, this was again last week's numbers, that 6 people out of every 10,000 people died from the flu, okay, using current numbers. Those same numbers, it was almost 700 people will die from the coronavirus out of every 10,000. So do you see why the coronavirus has the CDC concerned? It's about the proportion of people that are possibly going to die from it. Out of 10,000 to 10,000, 6 people will die of the flu. Out of 10,000 people with the corona, the estimate is close to 700. So, that's where the difference is. Right now in the United States, that's based off of China and stuff. In the United States, we're seeing something more along the lines of 100 people. But 100 people versus 6, that's a big difference. So that's where the difference comes in. So that's why we want to look at proportion. In today's lecture that I'm going to go over and teach about proportion, I'm going to talk about proportion and why it's important to know. So here's the key part on this one right here. Excuse me. This is a consistent fact. Just know that, write it down. If you are doing a confidence interval on proportion, you always, always, always use Z. You never use T. It is always Z, period. Okay? It is never T. So when you're reading through a word problem and you see the word proportion, you're going to use Z every single time. Okay? So let's look at the next problem here. This is going to be a Z problem. Let's look at the next. Oh, hold on. I can't advance on that because that's my thing here. Let's look at the next one. It says a random sample of 730 shoppers showed that 620 remained loyal to their favorite brands during the past year. Construct a 99% confidence interval for the proportion of shoppers that remain loyal to their favorite brands. Everybody answer, is this a T or a Z distribution? Thank you for answering. Excellent. Very good. Okay. We'll go over on Thursday we'll work proportions a lot on Thursday. Okay. Let's look at this next one. It says a 2014 survey asked 920 women, 775 men, what they thought about the ideal number of children for a family would be. The average number for a woman was 2.7, and the average number for men was 2.36. So I guess if we can do that, well, they're not too far off. Assume that the population standard deviation for the women is 0.89 and the population standard deviation for men is 0.85. Construct a 95% confidence interval for the difference of means. Again, this topic is going to be on Thursday's lecture, but I want you to take a stab right now. Is this a T or is this a Z, and why? I want you to put down why. I've got one answer in. Anybody else? There we go. 2 answers. Anybody else want to take a guess? 3. Good job. Anybody else? Okay, so it is going to be a Z because it says population standard deviation, population standard deviation. When you see population standard deviation, even when it's talking about the difference of things, both of these are population standard deviations, so they're both going to be Z. Very good, very good. I think we have time to maybe look at one more. It says the study investigated if cell phone use impacts student driver retention times. There were two groups, 20 students assigned to the cell phone group, while 20 students were assigned to the control group. The experiment measured the response time to traffic lights. For cell phone group, the mean was 586.2 with a standard deviation of 88. And for the control group, the mean was 537.8 with a standard deviation of 68.4. Construct a 90% confidence interval for the mean response time between the cell phone and the control groups. Is this a Z or a T distribution? Let me see what you have here. Excellent. Oh, let's see here. Hold it. No. Hold it. Sorry, I was reading a text from a student who's panicked on college algebra. No. Everybody put Z? Everybody put Z? Oh, let's go back and double check this. The experiment response time, for the cell group, the mean was 586.2 with a standard deviation of 88. So it says the experiment measured the response time to traffic lights. For the cell group, the mean time. So for the 20 students in the cell group, the mean was this. For those 20 students, the standard deviation was this. For the control group, the 20 students that we did in the control group, their mean was this. The standard deviation for those 20 students in that sample was this. So this should all be T. So it should be T. Yes, it's a random sample. Random sample from our population. So look for those keywords. Everybody else good? Yep, good job. If they split into groups, it's T. It's not if they split into groups, it's the fact that each group you had the sample standard deviation. You go back to, do you know the sample standard deviation or do you not know the sample standard deviation? Do I still have down here the, let me open up my formula sheet here. To my formula sheet. So the formula sheet, this one here is for the difference of two populations. And it says if sigma 1 or sigma 2, if either one of them are unknown, in this case, both were unknown, we were using S for both, it's going to be a T, okay? And you'll notice over here on your proportion, it's always a Z for your proportion. Okay, is everybody good on that now? Let's see here. Alex again, okay, good. Alex again, it has to do with whether or not you know sigma. Okay, I'm going to let you guys go because I have a few college students or college algebra students that are in a panic, and I know I'm cutting you guys short, but I hope you'll understand. I don't want to leave them in a lurch coming up to their exam. They kind of need some information from me, and I'd like to be there for them. Thank you, and I will see you guys on Thursday. Your lecture video, I have not recorded yet. I have to get to town, and I won't be home from town till about 6 tonight. So I will record your video this evening. It takes about 5 hours for me to get from start to finish and upload it with a link for you guys. And so that will occur probably about midnight. I want to point out one last thing in here, okay, under Canvas. Here are the study session notes in PDF format. So if you missed one of our prior study sessions on a Tuesday or Thursday, I am downloading all of the notes in PDF format so that you can come in here and you can look at those and you can see exactly what your classmates and I went over. If it will ever load on my computer, it will show you that. It's just going to take forever. So I'm going to skip this, I guess, for right this second. But they're PDF, okay, and you can download them if you end up with a faster computer link than I do. Coming back over here to home, also right underneath this, you see it's study session notes. And then so our lectures, I guess I've got your lectures. I'm going to create probably a different one, but video lessons and helps for your lectures, Mod 6. I might keep putting them in here, but in here also, I probably will put a study session video link. So create a new little mod here, and like our video from today will get put in there, the link to that. So in case there was anything about today that you got confused on or that you wanted to go back and double check, you'll have that video link. Okay, so everybody have a good day. Thank you so much, and I will see you all on Thursday. Text and email me if you have any questions concerning any work. Take care. I'm sorry, what? Yay!
As he said, just in case there's any specials.